Okay, good morning. Welcome to
SuperMath160.
SuperMath160. So this morning we were starting our section on pyramids, and you and I walked through calculating the volume of a tetrahedron with side length 6. So now for the movie, we're just going to do a tetrahedron with side length 8, and I want to see if you can walk through the argument, but I bet it'll be harder to do with me holding the pen.
Alright.
How do we find the volume of a tetrahedron with side length 8? What do we do?
Well, we need the volume of any pyramid is the area of the base times the height of the pyramid all over 3.
Okay. So for any pyramid, volume is 1/3 base area of the base times the height. Good. Good start.
Well, the area of the base is, this is going to be the base. It's 8 times 4√3 over 2, 16√3.
Okay, so the area of the base is 16√3.
Times something over 3.
Okay.
Well, the height, erase, oh yeah, I have the eraser. We draw the base again. This is where the height will hit.
Okay.
And the fact that this is an equilateral triangle might help us. Because we need to find this distance so that we can use the Pythagorean theorem. Because we know this is 8, we find the height and that distance. Well, if we find this distance, we can use it to find the height.
Okay.
Well, we're going to have some right triangles. Actually, I can use this as the tetrahedron now that I drew it like this.
Alright.
So, if you imagine we drop this height down here, we have some right triangles, like this, that are congruent.
Okay.
And the fact that they're congruent means that these three lines are the same.
Okay.
Which means that this is the center of the circumscribed circle.
Alright.
And it also means it's the centroid, because it's the center of the medians. Because the medians are the perpendicular bisectors in this case.
Okay.
So,
I didn't do you any favors by picking 8 as the number, but sorry about that.
get a good triangle.
So, okay. We're not going for perfection here. There you go.
Alright.
There's your triangle to use.
So, here are the medians. And this is the distance we're trying to figure out.
Okay.
Which is equal, these three distances are equal.
Alright.
And we know the whole distance, this whole height, is 4√3.
Yeah.
So, if we look at this triangle, it's this triangle that we need to look at.
Alright.
Since it's half, since this splits the side in half, this is 4. This side is 4/√3. And this side is 8/√3.
Okay, because it's a 30, 60, 90 triangle.
Yeah.
Just leave it as 8/√3 for now, because I want to save a little time.
So we have our triangle, 8/√3, the height, whatever that is, and 8.
Okay.
So 8 squared plus, it would be 64 thirds. This 164. So h squared is 128 thirds.
Okay.
So h is the square root of 128 thirds. 128 is 8 root 2. So 128 is 8 root 2.
Okay.
So it's 8 root 2 over the square root of 3.
Okay, good. So that's our height.
And so over root 3.
Okay.
So the root 3's can cancel. And we're left with a 128 thirds.
Not quite.
Well, 80. Oh yeah, 128 root 2.
Yeah, don't forget about that root 2. 128 root 2 over 3. Good. Good job. Good. It's a tough calculation, so nice job working through that. Good work this morning. Good work. Here's the cap.